So the beginning of Chapter 7, this is a pre-Chapter 7 notes, and we're going to do a quick review of properties of exponents. So we see this expression right here, a raised to the power of n. And we're recalling this from our Algebra 1 days. What is the base? The base is a. What is the exponent? The exponent here in this example is n. Our first couple of examples here is taking a trip down memory lane and simplifying this expression. So we have -4 raised to the third power. And then we're going to multiply it with 2 squared. Now, remember, the parentheses mean that the negative is also being raised to the power of 3. Well, a negative to an odd power is still negative. When you cube a 4, you get 64. So this number equals -64 times 2 squared, the base is 2. 2 squared is 4. And when we simplify this, 64 times 4 is 256. Negative times positive is negative. What's different in example 2? Well, there's no parentheses around the -3. So really, only the 3 is being squared. Okay, that's your base to that power. This is like -1 times 3 squared. When you think of it that way, this is -1 times 3 squared times 2 to the power of 4. All right, so this is going to be a negative number, right? 3 squared is 9. I'll keep the -1 out here. 2 to the 4th is 16. 9 times 16 is 144 times -1 is -144. So the biggest area where students make mistakes is knowing whether or not that negative, especially with an even power, is going to go positive or not. In this case, not, because there's no parentheses. All right, a quick review of the rules and the properties of exponents. It says, assume that a and b are real numbers, so no I going on here, and that m and n are integers. So when you have an expression, a to the m times a to the n, notice the bases are the same. And when the bases are the same, you add the exponents. This becomes a to the m plus n. So let's apply that to these two problems. 2 squared times 2 to the 4th is 2 to the 2 plus 4, or 2 to the power of 6. And of course, since I can raise 2 to the 6th power, I should raise 2 to the 6th power and get 64. All right, you could check it another way to see if this works. You know, we could do 2 squared is 4. 2 to the 4th is 16. And 4 times 16 is 64. So you get the same answer. And that's just proving that the property of exponents does work. This, though, is how you would do this on an assessment and in your homework. Why don't you try the next one? Okay, so hopefully you pause the video and you tried it on your own. 4 cubed times 4 squared equals 4 to the 3 plus 2, or 4 to the 5th power, which equals 1024. So you'll have to be able to call these properties of exponents fairly quickly. The negative exponent rule is next. If I have a base raised to a negative power, then we take the base and we move it to the denominator to make the exponent positive. And if our expression with the negative exponent is in the denominator already, we move it to the numerator to make the exponent become positive. So it's the switching from numerator to denominator that changes the sign, right? This is really now in the numerator because that's a to the n over 1. So if you see something like 2 raised to the negative 3 power, that's really 1 over 2 to the positive 3 power. And 2 cubed is 8, so I'm going to simplify this. Why don't you try the next one? Pause the video and try the next one. Okay. So we have to take the 3 to the negative 4 power and move it up. Okay, this really is over 1. And 3 to the 4th divided by 1 is 81. The zero exponent rule. Any real non-zero base raised to the power of 0 always equals 1. Doesn't matter how large it is or how small it is. Any real base, except for 0, raised to the 0 power equals 1. So, in our two examples, 5 to the power of 0 is 1. This one is a little bit different because, remember, this is the same as negative 1 times 4 to the 0 power. You have to understand what the base is. Okay, the base here is not negative 4 being raised to the 0 power. It's negative, or the opposite, of 4 raised to the 0 power. This equals negative 1, which we could add another example here to show you. Negative 4 in parentheses raised to the power of 0. Here's where you get your positive 1. So be careful with these. Students always make this mistake. They get these two confused. Okay, so if you have questions on these, reach out on the homework discussion or ask in class. I'm going to move on to page 2 and talk about the power rule. All right, the power rule. So we've got powers raised to powers. Notice I have a power on the inside and a power on the outside. So a to the m raised to the n gives us a to the m times n, which is different than when you add them. Okay, so here we've got 4 to the 3rd raised to the 2nd. When you see these parentheses, that indicates distributive property. This is 4 to the 3 times 2, not 3 plus 2. 4 to the 3 times 2 is 4 to the power of 6, which is 4,096. Why don't you pause the video and try the next one? All right, hopefully you were successful. Y to the negative 4 raised to the power of 5 becomes y to the negative 4 times 5 power, which is y to the negative 20th. And remember, exponential expressions are not simplified if you have negative exponents, so you have to move that y to the negative 20 to the denominator to get the exponent to be positive. All right, our quotient rule. Multiplication and division are inverses, so they sort of have similar powers here. Okay, notice the multiplication is of the same base. So if we compare it, the division here rather is of the same base. If we compare it to the multiplication of same base, here we added the exponents. And since division is the inverse of multiplication, the inverse of adding the exponents would be to subtract the exponents. Okay, so when you have same base again and you're dividing, that means you are going to then subtract those exponents. So in our first example for this part, bases are the same. So this becomes 4, and then you go top to bottom. It's 7 subtract 5. This division sign almost looks like a subtraction sign. 7 subtract 5. You can't subtract it from bottom to top. It's always top to bottom. Okay? 4 to the 7 minus 5 is really 4 squared is really 16 when you simplify it. Why don't you pause the video and try number 2? Okay, were you successful? Did you get 1 over x to the power of 8? X cubed divided by x to the 11th is x to the 3 minus 11, or x to the negative 8. Can't have a negative exponent, so we write it as 1 over x to the power of 8. You know, lots of times for these, I'm using the properties, but what I do, and I'll illustrate this to you with this problem. 4 to the 7 means 4 times itself 7 times. And 4 to the 5th means 4 times itself 5 times. So when I do these in my head, I always say, oh, well, okay, that divides out and becomes a 1. There's a numerator-denominator pair, another numerator-denominator pair, another numerator-denominator pair, and 1 more. What's left is 2 4s up top. That's 4 squared, which is 16. Okay, so in my mind, I say, all right, 5 of these kick out 5 of those, leaving me with 2 left in the top. If I apply that same rationale to number 2, I say 3 of these kick out 3 of those, leaving me with 8 in the bottom. Okay, so maybe that'll be a more efficient way for you to think about these problems. All right, now our illustrious products to power. Notice I have a product inside the parentheses, multiplication of 2 things, raised to that power of n. Folks, this is like AB times itself n times. So if it was AB squared, then it would be AB times AB, or A squared times B squared. Okay, so when it is a product raised to a power, you distribute the exponent. Notice there's no addition or subtraction between this A and B. That's because this is a product. So if I use that same rationale, 3x raised to the power of 3 is 3 raised to the power of 3 times x raised to the power of 3. 3 cubed is 27. And x to the power of 3 is simply x to the power of 3. And what's more is you could think of this as this is 3 to the 1 times x to the 1. So this is 3 to the 1 times 3 and x to the 1 times 3. Okay, because sometimes in here you might get, you know, higher exponent than just 1. Just know that you multiply those exponents. Like in example 2. Why don't you pause the video and try example 2. Okay, hopefully you paused that video and tried this on your own. Notice the negative is inside the parentheses. So I've got negative 5 inside the parentheses. To the exponent on negative 5 is 1. The exponent on r is 1. The exponent on s is 2. So this becomes negative 5 to the 1 times 2, r to the 1 times 2, s to the 2 times 2. Well, 1 times 2 is 2, 1 times 2 is 2, 2 times 2 is 4. Final answer, I have to take that negative to that even power, and when that happens, it becomes positive. So negative 5 times itself, negative 5 is positive 25, r squared s to the power of 4. And finally, our quotients to powers. Quotient meaning division. So I've got a quotient here being raised to a power. Again, you simply distribute the exponent to each base. Notice bases are not the same. All right, so knowing that property, this becomes 3 to the 6 times 2 power divided by 3 to the 4 times 2 power. 3 to the 6 times 2 is 3 to the 12th. This is 3 to the 8th. Folks, I can now use my properties of exponents when the bases are the same. I can subtract the exponents. Or I could say 8 of these kick out 8 of those, leaving me with 4 3s in the top. Right? I don't have to write the 1 as the denominator. It's going to divide out. Right? We saw that here. All of these divide out and become a 1. This is 4 squared over 1. Right? Because there's always a 1 here. I could write 1 times all of that, and down here, 1 times all of that. So the 1 is still there in the bottom. Okay? 3 raised to the power of 4 is 81. All right, last example. Please pause the video and try this one on your own. Okay, hoping you paused the video and tried this one on your own. Y to the 4th divided by y to the negative 9. That quotient raised to the power of 2. Distribute the exponent. This becomes y to the 4 times 2, or y to the 8th, over y to the negative 9 times 2, or y to the negative 18. Property of exponents, same base, division, you subtract the exponents. This becomes 8, subtract negative 18. The opposite of a negative is a positive, so this becomes y to the 8 plus 18. You add the exponents, you get y to the 26th power. Once I get it to this step here, I could, if I wanted to, just move this bottom to the top. And that changes the sign of the exponent. Then this becomes multiplication. So I don't have to subtract exponents here. I'm still using the properties. Okay, so when I move it from the bottom to the top, all right, that's property of negative exponent. Move it up to the top. If it's in the bottom, negative, it becomes positive. Same base, add the exponents. You get the same answer of y to the power of 26. Okay, you have some homework problems to try to get reaccustomed and reacquainted with these properties of exponents. If you have questions, please don't hesitate to post on the homework discussion or come into Google Meet or ask a question in class. Have a great day.